Woo-wee, Ben. It is a hot day today.
It really is. I have a water bottle if you want one.
Thanks, dude. True friend.
The radius of the bottle is 5 inches. And since the water is exiting the bottle at a rate of -5 pi times the square root of the height of the water, we can do a lot of stuff with this information.
A lot of people say that you can't use calculus when you're done with the class. But, as I have come to find, that you can use math on any situation. Here's an example. Using the information we found, show that dh over dt equals negative square root of h over 5.
That's a good question. Let's see here. Because I know that the radius is 5, I can plug that into the initial volume formula. So that would mean that the volume equals 25 pi h. If I was to derive that, or no, it doesn't equal that. Wait, does it?
Actually, what he meant to say was that you derive both sides, so then you have the derivative of the volume equal 25 pi times the derivative of the height equals -5 pi times the square root of the height, which was shown earlier in the problem. Then you have the dh over dt equals -5 pi over the square root of the height over 25 pi, which is equal to negative square root of h over 5. Given that h equals 17 at the starting time 0, solve for the differential equation dh over dt equals negative square root of h over 5 for h as a function of t.
Let me think about that one for a second. Oh, I know what to do. The first thing I'm going to do is multiply by dt on both sides to eliminate the fraction on the left side. So that leaves me with dh equals negative square root of h over 5 dt. The next thing I'm going to do is divide by square root of h. So that's going to give me 1 over square root of h dh equals negative 1/5 dt. That leaves me with the last step to integrate. So that is, integrating that will give me 2 square root of h equals negative 1/5 t plus c. Gotta remember that plus c. So then I'm just going to go ahead and plug in the information you gave, which is 17 is h, so that's going to be 2 times the square root of 17 equals, you said 0 is t, so that's going to make this expression right here 0, plus c. That leaves the function of h to equal the quantity of negative 1/10 t plus square root of 17 squared.
At what time t would the water bottle be empty?
Because 0 squared is 0, I can go ahead and get rid of this and set that equal to 0. So that's going to be 0 equals negative 1/10 t plus square root of 17. I'm going to subtract square root of 17 on both sides. So negative square root of 17 equals negative 1/10 t. And then I'm going to multiply by negative 10 to eliminate the fraction on that side and just have the variable. So that is going to give me 10 times the square root of 17 equals t, which is my final answer.